Hi there, this is video section 1.2 on properties of real numbers. So if we look at our your video worksheet, note sheet, take it out. Our vocabulary is all of real numbers and classifying them. Our objectives are classifying real numbers and using the properties of real numbers to evaluate expressions. Now remember, we learned what an expression was in section 1.1. So let's just go quickly and just do a refresher. This should all be just a review for you. Natural numbers and counting numbers are simply what they are, counting numbers. You start with 1 and work your way up. So natural or counting numbers, 1, 2, 3, ... These are braces. Then you have whole numbers, which are simply natural numbers and counting numbers plus 0. That's it. Then you have integers. Integers are simply whole numbers and their opposites. So you're going to have the ellipses on both sides. That's what these things, little dots, are called, in case you're wondering. 1, 2, 3, ... These are integers. Then you have rational numbers. So rational numbers, this is really important, is the quotient of two integers. What does quotient mean? It means division. What's one way you can write it as a fraction? So 3/4 is a rational number because it's the quotient of two integers, 3 and 4 integers. Now, what about -1 and 1/2? Well, can't this be rewritten as an improper fraction? Now I have the quotient of two integers. 3 or -3 and divided by +2 are both integers. What about the number 5? Yes, because everything's implied divide by 1. So I can write this in the form of the quotient. What about 0.5? Yes, because can't this be written to say 1/2? What about the square root of 4? Well, the square root of 4 is simply a perfect square, which equals 2, which can be written over 1. What about repeating decimal, 0.3? Well, isn't 0.333 can be written in a fraction, quotient of two integers? So this is a really important one, is the rational numbers. And if you look at your chart here, right here, you see you have natural counting numbers, whole numbers, integers, rational, and then I stands for irrational. Irrational numbers are simply going to be your numbers that are neither repeat nor terminate, that go on forever. For instance, pi, or square root of 3, because it's not a perfect square. These numbers, if you get their decimal forms, they go on forever. There is no repeating pattern in them, so therefore they're irrational. And altogether, all of these numbers are real numbers. So let's name the sets of numbers to which each of these belong. Example 1. So -23, is it a natural counting number? No. Is it a whole number? No, because there's no negatives in whole. Is it an integer? Yes. Is it a rational number? Yes. Irrational? No, but it's a real. So those are the categories for B. What about the square root of 50? Well, square root of 50 can be simplified as 5 square root of 2. Square root of 2 is not a perfect square, so this is simply an irrational and a real number. Now let's look at -4/9. Is it a natural number? Nope. Is it a whole number? No. Is it an integer? No. It's negative, but it is not an integer, because we said integers are simply whole numbers and their opposite. And 4/9 by itself is not a whole number. So is it a rational? Yes, because it's a quotient of two integers. So it's a rational and an integer. And a real number. Not. Okay, so let's move down to the next page. And these are some properties that you learned a long time ago. Commutative property applies to both addition and multiplication. So basically it just says you can turn around a plus b is equal to b plus a, and a times b is equal to b times a, which 2 plus 3 equals 3 plus 2. 2 times 3 equals 3 times 2. Associate property is similar, except it deals with a grouping. It says you can regroup addition or multiplication and they're still going to be equal. Identity means the number keeps its identity. So a number plus 0 is itself. That's the addition identity problem. The identity problem of multiplication is anything times 1 is itself. Then we have the additive and multiplicative inverses. Basically, the additive inverses says a number plus its opposite will equal 0. So it goes from positive to negative or negative to positive. The multiplicative inverse says anything times its reciprocal equals 1. And we'll look at an example in just one second. Closure just says a plus b is a real number and a times b is a real number. Distributive says if you have a number outside of parentheses with more than one term inside, you can multiply and distribute that number to every term inside, and you can break parentheses. So here, a times b plus c can equal to ab plus ac. So let's look at here. Example 2. They want us to name the property illustrated. Well, they've just did what? It's multiplication, and they've just simply regrouped it. So this would be the associate property of multiplication. What about example 3? They want the additive inverse and multiplicative inverse. So it's negative 5/8. So negative 5/8. You want its opposite. It's going to be positive 5/8. Its multiplicative inverse, remember it's reciprocal, or 1 divided by that number, which makes it its reciprocal. It's still negative. Now it's just 8/5. Okay. So pause this, and I want you to do 3a and 3b. Okay, check your answers with a key that's posted online. Now let's simplify an expression. We're going to use the distributive property here, and we're going to simply distribute that value. So we're going to let's write the problem, 3 times 2q plus r plus 5 times 4q minus 7r. So they want us to simply simplify, so we have to distribute first in order to break the parentheses. 3 times 2q is 6q. 3 times r is 3r. Positive 5 times 4q is 20q. Positive 5 times negative 7r is negative 35r. Now, do we have any like terms? These two are like terms, so that's 26q. Okay, and then you got these two are like terms, which is minus 32r. And that's as far as you can go because these two aren't like terms, and this would be your solution. Alrighty. So I want you to pause this and do the last one. And that is the end of the video. Check your answers, and we'll see you in class.